Invisible to the naked eye, yet indispensable for life on Earth. A vast, unseen force surrounds our planet, a protective shield forged in the depths of its core. This is the geomagnetic shield, Earth's magnetic field, a cosmic guardian that deflects deadly solar winds and cosmic radiation, preserving the fragile balance of life. Without it, our blue world would be a barren wasteland, exposed to the full fury of the sun's tempestuous storms and the cold vacuum of space. But what exactly is this shield? How does it form, and how has it shaped the destiny of our planet? Join us as we journey through the mysteries of the Earth's magnetosphere, the silent guardian that beats like a heart beneath our feet and stretches out into the heavens above. Beneath our feet, nearly 3,000 kilometers beneath the crust, lies a restless ocean of molten iron and nickel. This swirling, churning metallic sea is the beating heart of Earth's magnetic shield, the dynamo that powers our planet's protective force field. But how does this inferno deep within a rocky world create an invisible, yet vital, shield that stretches tens of thousands of kilometers into space? The answer lies in the physics of magnetism and fluid dynamics. As the Earth spins on its axis, the convecting molten metal generates electric currents, which in turn produce magnetic fields. This self-sustaining dynamo effect weaves an invisible web of magnetic lines around the globe, forming the magnetosphere, Earth's first line of defense against the hazards of space. Scientists have studied this phenomenon for centuries, but it is only in recent decades that advanced satellites and simulations have unveiled the dynamic complexity of this magnetic heart. It is a living system, fluctuating and shifting, responding to the internal rhythms of the planet and the cosmic environment beyond. Billions of years ago, Earth was a violent, molten world, chaotic and hostile, as asteroid impacts and volcanic eruptions reshaped its surface. But deep inside, a slow transformation was underway. As the planet cooled, the iron-rich core began to crystallize and spin, initiating the geodynamo, the primordial engine that would birth the magnetic shield. This early magnetic field was not as stable as the one we know today. It flickered, weakened, and reversed many times in Earth's ancient past. Yet it provided the first crucial layer of protection against the relentless solar wind, a stream of charged particles emitted by our young sun. Without this shield, Earth's atmosphere could have been stripped away, leaving it barren and lifeless like its neighboring planets, Mars and Venus. The magnetosphere, born from Earth's fiery heart, was the silent architect of habitability. Beyond the serene blue skies and tranquil seas lies an invisible battleground, a constant, turbulent dance between Earth's magnetic shield and the fierce solar wind. The solar wind is a ceaseless stream of charged particles, electrons, and protons hurled from the sun's fiery surface at speeds of over 1,000,000 miles per hour. When this cosmic gale encounters Earth, it meets the geomagnetic shield, a guardian that bends and deflects the solar storm, safeguarding our atmosphere and life itself. But this battle is far from static. The magnetosphere is flexible and alive, compressing, stretching, and reshaping as solar winds push against it. This dynamic interaction fuels phenomena both beautiful and powerful, from shimmering auroras to sudden magnetic storms that can disrupt satellites and power grids. Understanding this cosmic dance is key to unlocking the secrets of space weather and protecting our modern world. As the solar wind's charged particles slam into Earth's magnetic shield, they become trapped and funnel toward the poles. Here, in the upper atmosphere, they collide with gases, oxygen and nitrogen, igniting a celestial light show known as the Aurora Borealis in the north and Aurora Australia in the south. These shimmering curtains of green, red, pink, and violet dance across the night sky, a visible veil of the invisible forces that protect our world. For centuries, auroras have inspired myths and legends, revered as messages from the gods or spirits. Today, they remain a reminder of the powerful connection between our planet and the sun, a cosmic performance that reveals the hidden workings of the geomagnetic shield. Earth's magnetic poles are not fixed, they wander, drift, and occasionally flip completely in a phenomenon known as geomagnetic reversal. These flips have occurred many times over the planet's history, sometimes rapidly, other times gradually over thousands of years. But what triggers these shifts? And what do they mean for life on Earth? Geological records reveal evidence of these pole reversals etched in ancient lava flows and sediment layers, telling a story of a shield in flux. During a reversal, the magnetic field weakens, potentially exposing Earth to increased radiation. Could a future pole reversal threaten our technology, ecosystems, or even human survival? Scientists monitor the magnetic pole's movements closely, seeking answers to one of Earth's most dramatic magnetic mysteries. Throughout Earth's long history, life has endured many cataclysms, mass extinctions that reshaped the evolutionary path. Some scientists theorize that geomagnetic field reversals, with their periods of weakened shielding, may have played a role in these biological upheavals. Increased cosmic radiation during weakened magnetic fields could have damaged DNA, affected climate, or disrupted ecosystems. Yet, the fossil record shows life's remarkable resilience, adapting and flourishing despite magnetic turmoil. The relationship between magnetic field reversals and extinctions remains a subject of intense research and debate, an enigma bridging geology, biology, and astronomy. Encircling Earth like invisible armor are two immense donut-shaped zones of charged particles, the Van Allen radiation belts. Discovered in 1958 by the first American satellite, these belts trap high-energy particles from the solar wind and cosmic rays, protecting the surface from lethal radiation. But they also pose hazards for spacecraft and astronauts, requiring careful navigation to avoid dangerous radiation exposure. The belts fluctuate in size and intensity with solar activity, illustrating the magnetosphere's dynamic nature. Understanding the Van Allen belts is crucial for space exploration and safeguarding our technologies from the cosmic environment beyond. The Sun, a blazing sphere of plasma, occasionally unleashes colossal eruptions known as coronal mass ejections, superstorms of charged particles hurtling through space at millions of miles per hour. When these solar tempests collide with Earth's geomagnetic shield, they can trigger powerful geomagnetic storms, disrupting satellites, communication systems, and power grids. The infamous Carrington event of 1859 stands as a stark reminder of the Sun's fury. A solar superstorm that plunged telegraph systems into chaos and ignited auroras as far south as the Caribbean. Today, our dependence on technology makes us more vulnerable than ever. Monitoring and forecasting space weather is critical to preparing for the next solar tempest and protecting our modern civilization. Earth's magnetic shield is not constant. It fluctuates in strength, sometimes weakening significantly over decades or centuries. These dips in magnetic intensity could leave parts of the planet exposed to increased cosmic radiation, impacting everything from climate to human health. Scientists have detected a current weakening in the South Atlantic anomaly, a region where the magnetic field is unusually weak, creating a hole in our shield. This anomaly poses risks for satellites passing through, causing malfunctions and data errors. Could this signal a larger shift in the geomagnetic shield stability? The answers remain elusive, but the consequences urge vigilance as we face an uncertain magnetic future. Beyond shielding Earth from cosmic hazards, the geomagnetic field serves as a silent compass for countless creatures. Migratory birds, sea turtles, whales, and even bacteria use Earth's magnetic cues to navigate vast distances with astonishing precision. Scientists continue to unravel how these living beings detect magnetic fields, whether through tiny iron crystals or specialized proteins sensitive to magnetic orientation. In parallel, humans have harnessed magnetism for centuries, from ancient compasses guiding explorers to modern GPS and satellite systems reliant on understanding geomagnetic conditions. This invisible force connects biology and technology, a testament to the magnetic shield's pervasive influence on life and progress. The Earth's magnetic shield has protected life for billions of years, but its future is uncertain. As the magnetic poles wander and the field weakens in regions, scientists race to understand what lies ahead. Will the next geomagnetic reversal bring chaos, or will life adapt as it always has? Emerging technologies and expanding space exploration demand deeper knowledge and robust forecasting to safeguard our planet and assets beyond. International collaboration in monitoring, research, and preparedness will be vital to navigating the magnetic challenges of tomorrow. The geomagnetic shield is more than a planetary feature, it is a dynamic force entwined with our survival and evolution. Our future depends on respecting, studying, and protecting this invisible guardian. Earth's geomagnetic shield is more than a scientific phenomenon, it is the heartbeat of our planet, a silent pulse connecting every living thing to the cosmos. This invisible force shapes climates, guides migrations, and guards against cosmic dangers unseen. As we uncover its secrets, we deepen our connection to Earth itself. In understanding the magnetic shield, we learn not only about our planet's past and present but also about the fragile thread that sustains life. The pulse of the planet is a call to stewardship, to respect, protect, and cherish the delicate balance that makes Earth a haven in the vast universe. The geomagnetic shield endures, a timeless guardian, whispering stories of cosmic dance and earthly resilience.